there's a generic formula for this, okay? The generic formula for sine, okay? The generic formula for sine inverse x on its own. So if y equals sine inverse x, the generic formula is 1 divided by a squared minus x squared, okay? Now, in the test you have to do basically a adjustment to that. A is always 1. That's learned off by heart. Okay? Now, what happens is it's sine inverse whatever is in the box by the differential of what's in the box. That is a learn off by heart part of this course, okay? Now we're basically going on to we'll start off with what this one here, right? Number 9. Now, in number 9, y is equal to sine inverse x over 2. What's in the box is x over 2. So here's what we have to do. The derivative is 1 divided by whatever a squared is. We know a squared is 1 squared. Minus what's in the box, which is x over 2 squared. And then finally differentiate what's in the box, which is going to be x over 2. You stop here and then you start squaring stuff out. You're going to get 1 minus x squared over 4. And then on the other side, what happens when you differentiate x over 2?
X minus 2.
Now, it's minus a half. Now some people might ask me, why didn't you do the quotient rule for that? It's a fraction. The truth is you can do the quotient rule for that. But what I said to you guys before is if you have a number in front of x, and this is a learn off, any number in front of x, when you differentiate it, only leaves that number left over. So the answer is a half. Much quicker than the quotient rule for it. Look at this square root sign. And now if I was to work on this part on its own, it'll turn into this. Do you see what I did there? I got a common factor. Then what I'm doing next is I'm going to break it up into top and bottom. And that root 4 there becomes a 2. Okay? Now, when you're dividing by this, you can then bring it up and turn it upside down. So it's going to be 1 multiplied by 2 over the square root of 4 minus x squared. And then it's multiplied by a half. And then you can see the 2's cancel. And our answer is going to be 1 over square root of 4 minus x squared. Right, reasonably tough question because of the fraction.
Would it not be u 4 minus x squared of 4 minus x squared because you cross multiply?
I'm not, sorry, explain your thought process there.
I don't know.
What you're seeing here, now guys, some of you were struggling with the product rule yesterday. I'm going to show you 2 questions that are similar looking, but treated completely differently. Okay, this is the question 12. As we can see here. Now, I could write a question like this. One of them is a product rule, the other one isn't. The first one is a product rule because they're being multiplied by each other. This one here to the left is being multiplied by the one to the right. The reason why I know that is there's no signs in between them. Do you got that? Now, however, the one on the bottom is 2 separate questions, so to speak. I differentiate 6x on its own. Wherever the derivative is, right, differentiate this, and then add it on together. Okay? Do you understand the difference? Now, I've identified this as a quotient drill, or sorry, a product drill. You can only split it in a certain way. I can't split it like this. Now, why can't I split it like this? Because tan inverse has to have an angle to go with it. Okay? So, and if I was to split it like this, you're still going to have to do a product rule because there's another split in that part again. So you're going to separate out the variables where possible. The variables are the x. If you can put one x to one side, the other x to the other side, you're in a much better position to do the question. Now, u equals 6x, du dx equals 6, phi equals tan inverse 2x. Now, write down the generic rule for tan inverse from your notes. Tan inverse x is, what is it again, guys?
A over A squared.
A over A squared plus X squared. Now guys, replace the X with what, guys? A box. It's whatever is in the box, and then you gotta differentiate whatever is in the box. That's the missing part. Represent the X's as boxes and differentiate whatever's in the box. So, okay. So what we're going to get here is this. The y dx ends up to be equal to A, which is always 1. In this case it's 2x, so it's going to be 2x squared on the bottom. Differentiate what's in the box, so I have to differentiate 2x. And that's going to leave me 2 over 1 plus 4x squared. Now that I've done that, that is what the v dx is. It's only the v dx. I still haven't actually started any of the actual. I still haven't filled in the product rule to begin with. So once you complete your list of what the u dx is, what the v dx is, then you do the product rule. Now I was asked another question yesterday, and this was a good question to ask. Phi du dx plus u dv dx is the product rule. Now, each one represents its own number. V is a number, du dx is a number, u is a number, and dv dx is a number. I'm going to multiply two sets of two different numbers, then add them together. Okay? So what I'm going to get is v, which is tan inverse 2x. Tan inverse 2x multiplied by du dx, which is 6. Plus u times the v dx, which is going to be 6x, multiplied by the v dx, which is 2 over 1 plus 4x squared. When you're done with this, the answer is simply going to be 6 tan inverse 2x. You can't make that tan inverse 12x. Why not? It's the angle, so the number goes on the outside. Multiply in, and we get 12x over 1 plus 4x squared, and you can leave it there if you want. Okay, moving on. What we should do next is we should we're currently on this part. Okay, so example would be if u equals 1 plus x divided by 1 minus x, show that when you differentiate u, you get 2 over 1 minus x squared. Now the reason why I know this is a quotient rule is there's a variable on top. What I mean by a variable is there's an x on top, there's an x on the bottom. Okay? Alright. They are the same variable, but they're the same letter, but they're top and bottom. Okay? Now what we're going to do is we're going to get the derivative of this. Okay? So it's phi times the u dx minus u times the v dx all over phi squared. Now, if you're not comfortable with this being called u, just pretend it's something else, like L, and that's the L dx, so you don't get mixed up with what u and v actually is. Okay? So, u in this case is the top number, which is 1 plus x. The u dx therefore equals 1. Phi is 1 minus x, therefore the v dx has to be minus 1. Put it into the scaffold here. 1 minus x, 1 plus x. Sorry, no, that's wrong. The u dx is 1. So excuse me. 1 minus x multiplied by 1. U, 1 plus x, multiplied by the v dx, which is minus 1, all over 1 minus x squared. Now look what happens here. Okay, when we do this out, what we're going to have is we're going to be 1 minus x. It's going to be plus 1 plus x, because that minus by minus gives you plus. Okay. Alright, so then what we're going to do is 2 over 1 minus x squared. Okay, and that's what we're asked to do there. Now that that's done, you're now on the next part. Okay, next part's a difficult question, and what it's going to ask you to do is it says y equals tan inverse 1 plus x 1 minus x. Now what you're going to notice is this question is exactly the same as the first part. Do you see the way that is? This box here is what we just did. We just differentiated what's here. Now, remember the general rule. When y equals tan inverse x, the general rule then is dy dx ends up to be a squared over a squared plus x squared. Now we have to make our adjustment to this because it's not in the tables. Okay? And what we're going to get is, and then we have to differentiate what's in the box. So it's going to be a squared divided by a squared plus the box squared divided by the derivative of the box. Connor? Okay. So what you get next is this, okay? What you're going to get is, you're going to do what you did last time. A is 1. We said A is always 1. It's going to be 1 squared divided by 1 squared plus 1 plus x over 1 minus x squared. Differentiate what's in the box. Now what's the good thing about differentiating what's in the box? We've already done it in part 1. So this is a question within a question, as you were saying, Connor. So this is the front part, but this part in itself is its own question. And actually we answered it in part 1. That's 2 over 1 minus x squared. Okay, so that's going to be 2 over 1 minus x squared. What we need to do next is we need to multiply all this out. Now, what you could do to save a bit of time is, especially if you're tending to use pencil, rub the two of them out, and it's the top bracket squared and the bottom bracket squared. For those of you who don't understand that, 2 over 3 to be squared is the same thing as 2 squared over 3 squared. It's the same thing. Okay? Now that that's done, what you're going to have next is we're going to have to get a lowest common denominator. Now, see this number 1 here? This number 1 might as well not have 1 squared in it. So take out the squared. 1 squared is 1. We need the same denominator. So what I'm going to do next is I'm going to change the number 1 into 1 minus x squared. 1 minus x squared divided by 1 minus x squared. Right? I'm going to square out the 1 on top. See the blue one? Now, you got to realise what's on the same level. At the moment, this here is on the same level. The 1 squared and the 2 are on the same level. The x minus 1 squared, the x minus 1 squared, and that 1 minus x squared are on the same level. I do, however, have to put them in brackets because they're going to be there. You have to add what's in the brackets before you can multiply out. Okay? So there's technically 3 levels going on right now. Okay? So the first level is going to be 2 on top. Nothing else to worry about. Now level 2, it's quite difficult. I got to multiply everything else. So it's going to be 1 minus 2x plus x squared, and then I'm going to have to add on 1 plus 2x plus x squared. Alright? And then that's going to get multiplied by, once I'm done with that, it's going to get multiplied by 1 minus x squared. Now, this part on the bottom is still here as 1 minus x squared. We're then going to tidy this up. Now guys, if I had this in the exam, okay? If I had this in the exam, what would you tell me? Right, 2 multiplied by 4 over 3 divided by another 3. What could you do there? You could cancel the 3's, couldn't you? But, oh sorry, the square's on the outside.
Yeah, they're different.
Okay, sorry, no, the square's meant to be on the outside. No, they're there. Same, okay? Now that I've done that, they're ready to go. Okay, because I can divide the 2 trees here by each other. Okay. Now that that's done, what you're going to have next is this. You're going to have 2 divided by. Now we're going to have 1 plus 1, which is 2. 2 of them cancel. And then we're going to have 2x squared. Now we can factorise out 2. 2 into 1 plus x squared. 2's cancel. And round enough, we're going to have 1 into 1 plus x squared. That's the first derivative. Now, it brings me on to part 2. Verify that 2x times the first derivative squared plus the second derivative equals 0. I now need the second derivative. So I'm currently well invested here in this question. I need to find out what d2y dx squared is. Once again, quotient drill. Phi times du dx. What's du dx, guys? Phi is equal to 1 plus x squared dv dx. 2x. Okay. 1 plus x squared times 2x. Oh, sorry. My bad. Times 0. And if it's times 0, it doesn't exist. Okay. And then it's going to be 1 times dv dx, which is 2x, and that's all going to be divided by 1 plus x squared to be squared. The answer for the second derivative is minus 2x into 1 plus x squared to be squared. Alright, once I've done all this, I can go back to the top, and what I need to do is I need to accumulate. I have to write down 2 pieces of information. First piece of information, what my second derivative is. Second piece of information is what my first derivative is. Now I can rub everything else out. Don't need it anymore. So everything since the very beginning no longer serves a purpose. Now, what's going to happen next is move this all the way up and restart the question up here. Okay, now let's start off here. 2x multiplied by this one squared. What's this one squared? What's 1 squared? 1. So it's going to be 1 over, what's the bottom squared? 1 plus x squared to be squared, close bracket. Plus the second derivative, which is minus 2x over 1 plus x squared to be squared. And as you can see, it's going to be 2x over 1 plus x squared to be squared minus 2x over 1 plus x squared to be squared equals 0. And they're the same number, 0 equals 0, proven. Is that alright? Yeah. You're obviously